Imagine it's just after sunset. You look up expecting the moon. Instead, the moon ignites. 1.3 seconds later, every street light on Earth becomes decorative. The sky is no longer dark. It is aggressively daytime, and for a brief, deeply confusing moment, every object around you casts two shadows. Welcome to tonight's simulation. We replace the moon with a second sun, not a metaphor, not a bright lamp, a full solar copy at lunar distance, same mass, same radius, same luminosity. 384,400 kilometers away. Yes, this is absurd. That is why we run the model. Before we start, quick dashboard check. Suns in service. 2. Expected stable planetary configuration. 0. Step 0, geometry. For the first few minutes, the sky is the strangest thing humanity has ever seen. 2 stellar disks. 2 hard light sources. 2 shadow vectors crossing at weird angles on every wall, tree, and face. Photographers are thrilled for about 12 seconds. Then the heat arrives. Step 1. Light budget. Solar constant from our normal sun is about 1,361 watts per square meter at the top of Earth's atmosphere. Now place an identical sun where the moon was. Distance ratio to 1 astronomical unit is about 389 to 1. Brightness follows inverse square law. So the news source contributes roughly 151,000 times normal sunlight. Peak flux from the second sun lands around 205 megawatts per square meter. That is not bright. That is, surface chemistry now has opinions. Dashboard update. Shadow count 2. Local stellar flux 205 megawatts per square meter. UV index retired. Step 2. What surfaces do under that load? At this intensity, common materials do not gradually warm. Paint blisters, polymers decompose, asphalt softens, then chairs. Dark fabric spikes in temperature almost immediately. Window coatings fail. Sealants fail. Electronics housings fail. Anything with moisture starts driving steam from the inside out. The phrase "seek shade" becomes mathematically funny because shade still includes a second sun unless your blocker geometry is perfect. And yes, you still see 2 shadows. They get fuzzier as scattering rises, but they remain the signature image for a while. Step 3, water. Ponds and pools flash toward boil. Ocean skin layers transition to violent vapor production. Humidity climbs so fast that local weather stations look broken. Clouds do not drift in from the horizon. They build vertically like detonations, lit from below by what used to be moonlight and is now full stellar output. Coastal visibility drops behind expanding steam walls. Dashboard adds a row. Ocean state, phase transition in progress. Marine forecast, no. Step 4, atmosphere. Rapid heating from below and above destabilizes pressure structure. Convection cells expand fast, shear zones sharpen. Winds stop behaving like weather systems and start behaving like moving boundaries between survivable and non-survivable air. Jet stream maps turn into abstract art. Regional forecasts collapse first. Global forecasts follow. The old categories, calm, windy, stormy, stop being useful. New categories appear, near side and far side relative to the second sun. Step 5, infrastructure, which was designed for 1 sun. Power grids were not stress tested for direct radiative assault at megawatt scale. Transformer yards overheat, transmission lines sag, arc, and fail in cascades. Cooling systems in data centers hit limits. Backgap generators work briefly until intake air and coolant loops become the bigger problem. Runway surfaces deform. Fuel depots become thermal hazard. Comms networks fragment into local islands. Insurance forms do not include a checkbox for secondary star at lunar altitude. Step 6. Human timing windows. At first, everyone tries to interpret what they are seeing. Then everyone tries to decide whether this is permanent. Then everyone runs into physics. Exposure time outside contracts from minutes to seconds, depending on location and shielding. Hospitals switch from treatment logic to triage logic almost immediately. Emergency planning assumes roads, communications, and coordinated response. Those assumptions now have two shadows too. Step 7. Gravity clears its throat. A sun-mass object at lunar distance exerts about 898 meters per second squared toward itself. That is roughly 91 g. Earth's current orbital velocity around the real sun is about 30 kilometers per second. To orbit a sun-mass body at lunar distance, Earth would need roughly 587 kilometers per second sideways. So we are not under speed. We are in free fall with paperwork. Dashboard update. Orbital status, catastrophic decay. Required tangential velocity, 587 kilometers per second. Available tangential velocity, 30 kilometers per second. Gap unacceptable. Step 8. Differential gravity. The near side of Earth feels stronger pull than the far side. Difference across the planet rises to around 3 g. That is enough to drive extreme tidal deformation in rock, not just water. Lithosphere stress fields reorganize fast. Fault systems that were near critical unlock in clusters. Volcanic plumbing responds to pressure redistribution. The crust is not a rigid shell in this regime. It is a stressed membrane with mountains on it. Step 9. Roche logic. For an Earth density body around a Sun density primary, Roche limit is far outside lunar distance. We are deep inside it, which means Earth stays one coherent sphere is no longer the default assumption. Fragmentation pathways depend on angle, spin state, and timing. None of those pathways are lifestyle friendly. Step 10. Minute-by-minute compression. Minute 1. Global perception event. 2 suns, 2 shadows. Universal confusion. Minute 2. Surface heating becomes visibly destructive in exposed zones. Minute 3. Coastal vapor fronts start building serious vertical structure. Minute 4. Atmosphere over major regions shows ionization signatures and electrical instability. Minute 5. Grid failures propagate continent scale. Minute 6. Ocean-atmosphere coupling enters behavior no civilian model was tuned to handle. Minute 7. Seismicity rises in synchronized clusters. Minute 8. Near-side thermal and gravitational stress diverges sharply from far side. Minute 9. The sky itself loses familiar contrast. The blue channel washes out into a white-gold scatter field. Minute 10. 2 shadows smear at the edges, not because there is less light, but because there is too much medium in motion. Minute 11. Communications degrade from network to pockets. Minute 12. Orbital trajectory dominates all remaining discussion. Minute 13. Structural coherence metrics trend hard in the wrong direction. Minute 14. Any distinction between weather event and orbital disaster is now academic. Minute 15. Terminal interaction window opens. Depending on geometry, Earth may graze, fragment, partially accrete, or fully accrete into the nearby sun. Pick your branch. Every branch deletes tomorrow morning as a normal concept. Step 11. What the dashboard says at the end. It tries to render a final status card. Habitability, unavailable. Ocean recovery, ETA, not in this configuration. Biosphere continuity, interrupted. Night forecast, canceled. Shadow count, transitioning to irrelevant. System note. Please reduce local star count. And there is a quiet joke hidden in all of this. We started with a simple wish, brighter nights. Mission accomplished. For a short window, the planet gets the most dramatic sky in its history. 2 suns, 2 shadows, one impossible glow across every city, desert, and sea. Then the bill arrives from thermodynamics, fluid dynamics, orbital mechanics, and material science in a single combined invoice. Humans are very good at adapting. We adapted to ice ages, droughts, volcanoes, and impacts. But adaptation requires time. This scenario removes time first. The most honest line in the whole simulation is still the first visual. 2 shadows. They look beautiful. They are also the warning label. This has been Stardrift FM. Sleep well, if possible somewhere with only 1 sun.